Hey guys, in this video, we'll talk about several mainstream consensus mechanisms used in blockchain. First of all, what is a consensus mechanism? We presented the Byzantine generals problem in last video. These generals need to vote to make a final decision, a consensus about when to attack the enemy city, without the help of a trusted central party. Consensus mechanisms are designed to solve Byzantine generals' problem. So let's check the definition of consensus mechanism. A consensus mechanism is a fault-tolerant mechanism that is used to achieve a necessary agreement on a single data value or a single state of the network among distributed process or multi-agent system. Or we can say it's a way to make a consensus that can be trusted without needing to trust every individual. So consensus mechanism is like, hey guys, this is a procedure we're going to use to make sure everyone agree on something. That is a consensus. So I marked fault tolerant in red color here because that's one of the key merits of consensus mechanism. What is fault tolerant? It means this mechanism can keep working well with failure of some nodes. Or in this example, they can still get the enemy city, get a victory with some betrayal of some generals. So we said Byzantine generals problem existed in all distributed systems naturally, including peer-to-peer distributed system, blockchain. And in blockchain, the consensus need to made is the status of the blockchain. All nodes need to agree on a single history of transaction. Now let's see what kinds of consensus mechanisms are used in blockchain and how they work. We introduced proof of work before, but is proof of work the only consensus mechanism? Proof of work is the first consensus mechanism, but not the only one. These are other consensus mechanisms used in blockchain. Except proof of work, there are proof of stake, delegate proof of stake, proof of capacity. Now let's check them one by one. So proof of work, we mentioned, is a consensus mechanism that requires members of our network to expend effort in the form of computing power and to solve a mathematical puzzle to prevent anyone from gaming the system. And we have introduced that this effort and work is mining, and the proof is to find a nonce. Then, what are the pros and cons of proof of work? Is proof of work perfect? Actually, the biggest disadvantage of proof of work is uselessness of computations, because miners do a lot of work to find a nonce, then generate blocks. This process takes time and it consumes a lot of power. The energy usage is very high, and mining causes wear and tear to hardware, right? However, this calculation is not applicable to anywhere else. It cannot be applied to business, science, or any other field. So we call it uselessness of computations. This high energy usage actually guarantees the security of the blockchain network. Blockchain nodes are distributed over the world, and if you want to attack proof of work to get yourself free tokens, you will need to at least gain 51% computing power. And this attack called 51% attack. That's the only way you can take over a proof of work blockchain. Then after you take over 51% attack computing power, you need recalculating all the nonce again, redo all the mining again, and make like at least 51% nodes agree with the new state of the blockchain. It's a basically an impossible mission because the node is all over the world and it takes billions of dollars to build new nodes, like to compete with all the nodes. And even if an attacker successfully made this attack and gets like a public explorer, then the blockchain network is considered compromised, and this compromise will lead the outflow of users, and this will eventually move the blockchain token, the cryptocurrency price will down, right? So 51% attack is not a wise option, and it's not a profitable option either. So now we can see this disadvantage of proof of work we mentioned is not really a disadvantage. We should consider this high cost of computation a property of proof of work. It brings high cost but also security. These properties of proof of work actually make it a very secure mechanism, right? Now let's check what is proof of stake. Unlike proof of work based network, proof of stake are not reliant on mining. Instead, a technique called staking is performed in proof of stake. So in proof of work, a bunch of miners need to compete in mining, which is finding nonce. The first miner that found the nonce can generate a new block and get block reward. But in proof of stake, the probability of getting a new block is determined by the portion of a person's stake. There is no miner anymore, only validator. Validator gets reward from the transaction fee in the block. And compared to proof of work, this mechanism, proof of stake, it barely has energy cost. It's much more environmentally friendly. So now you might have some question about proof of stake. What is staking? Actually, staking is a process that nodes, or we can say people put up a certain amount of their cryptocurrency they already hold. So for a chance to be the entity that creates the new block, it depends the portion they put into staking pool. Then who will get chosen? Whoever is chosen to write the next block verifies the transaction, and as a reward gets to keep all the transaction fees as a reward. So if you are not chosen, tokens you put will get back to you. You will get your stake back, and the stake of the new block writer is held in like escrow. Like this staking you have put is not allowed to be spent. It's totally safe until the several new blocks are added. The process of choosing involved with not only the portion, the size of stake. It's also impacted by other features. So if validator they're found to cheat in this validating process, they will lose their stake, and by this way we can ensure these validators they are not doing anything bad. So let's check this impact. These three things will impact choose validator. So the first one is the size of stake. Like if you are a proof of stake node, and in this like generating new block process, the more token you staked, the higher the chance of you being chosen to validate. So you can get the reward of that new block, all the transaction fees. And the other thing is the age of token staked. The longer the token have been like unspent, the higher the chance of being chosen to validate. So once that stake is used to verify a block, its age will reset to 0. So this mechanism will make sure every node will get a chance, because if this time your token did not get chosen, then its age is getting older, right? And the token, the node get chosen, the age of their token will get reset to 0. And the third impact is it's a random selection. The lowest hash value combined with the largest stack is chosen to validate. So by this mechanism, the choose process of validator can be made sure is fair to all the nodes. So what's the difference of proof of work and proof of stake? If we imagine mining in proof of stake is like a race, like who wins the race can get the reward, then proof of stake is choosing a person who stakes more coins as a winner. Of course, as we mentioned, it's also related to the age of tokens, and it's like a pseudo random process. So most of proof of stake cryptocurrencies started out of proof of work, then switch over to proof of stake after they had plenty of coins to go around, and they have built a good ecosystem of users. So which means, for example, Ethereum is a cryptocurrency. They have switched over to proof of stake, but they were using proof of work. So now they are using proof of stake. So all the Ethereum coins the network has now is get by mining before. So how cryptocurrency like Ethereum switch over from proof of work to proof of stake? There must be some reasons, right? Reason one is apparently the usage. We have mentioned the energy consumed in proof of stake compared to proof of work is like nothing. Proof of work consume a lot of computing power, and proof of stake actually can make blockchain more secure. And why is that? Let's see. First, the threat of 51% attack still exists on proof of stake, as it does on proof of work. Validator who hold large amounts of blockchain token or cryptocurrency may have an outsized amount of influence on a proof of stake system, right? Because we mentioned the portion, the size of token they put will impact their power to generate new block. So let's use Ethereum as an example. One Ethereum coins cost more than $1,000. If an attacker wants to attack Ethereum proof of stake network, he needs like billions or even trillions of money to get 51% coins. This cost is too high to operate an attack. So even if the attacker succeed to attack, like we mentioned, the blockchain will be considered compromised and the coin value crash down. Attacker will make no profit. So that's why proof of stake can help blockchain to stop attacks. And proof of work and proof of stake are the most prevalent consensus mechanism in blockchain world. These two are the most important. Now let's check what is delegated proof of stake. This mechanism works similarly with proof of stake, but it features a voting and delegation mechanism that makes the process even more democratic. So delegated proof of stake is like an evolution of proof of stake concept. User of the network can vote and elect delegates to validate the next block. And delegates are also called witness or block producer. So using delegated proof of stake, we can vote on delegates by pulling our token into a staking pool and link those tokens to a particular delegate. We don't need to physically transfer our token to another wallet. We can just stake the token to a staking pool, and the number of delegates is limited. Usually it's between 20 to 100, and elected delegates receive the transaction fee from validate block, and the reward is then shared with users who pooled their token in the successful delegates pool. The more you stake, the higher a share of block reward you will receive. The rewards are shared based on each user's stake. So if your stake represents 5% of the total staking balance, you would receive 5% of the block reward. Compared to proof of stake, apparently delegate proof of stake is a more democratic way of choosing who verifies the next block, right? It allows a more diverse group of people to participate in the process, since it's based on earned reputation as a lawful staker and not overall wealth. Additionally, because there are a limited number of validators, delegate proof of stake allows network to reach consensus more quickly. Now let's check another popular consensus mechanism, proof of space and time, aka proof of capacity. It's a mechanism that uses digital storage space as a requirement to participate a network. It sets up a way to put some information in a hard drive, and in the future the network will randomly check if that information is still there. It stores completely useless data. It sounds strange, but it is an effective consensus mechanism. Blockchain Chia is using this mechanism. Of course, instead of storing useless data, there are blockchains that uses proof of capacity that actually store useful data too, such as Filecoin. People pay for using Filecoin to use its storage that cross the network around the world. So people who provide storage for Filecoin network will get paid by its token, which is Filecoin. There are also other consensus mechanisms that have been using, like proof of burn, proof of wait, but these four we have explained are the most common consensus mechanism. Thanks for watching. See you in the next one.